Hello all, my name is Miguel Saavedra, and along with Gustavo Salazar and Victor Romero, we are going to present our work High-Level Camera-LiDAR Fusion for 3D Object Detection with Machine Learning. We are here on representing the Universidad Autónoma de Occidente in Cali, Colombia, and the Robotics and Autonomous Systems hotbed. First of all, I would like to start with the motivation of this work. 3D object detection is a technique that allows autonomous agents to estimate the relative pose of multiple objects neighboring an ego vehicle. However, the astonishing results presented by deep learning models used to address this issue are generally occluded by the vast need of computational resources, overcomplicated model, millions of human-labeled datasets are generally required, and the need to process multiple sensor input as fast as possible. As an example of this, we compare our work with a baseline named Center Fusion, which uses a Titan RTX GPU to achieve a processing time of 11 FPS. Therefore, we decided to tackle the aforementioned by using a Frostum-based approach employing classical machine learning techniques with a small bunch of data from the nuisance dataset. We propose a pipeline to detect vehicles in the 3D space leveraging the utilization of major 2D object detectors using camera-LiDAR data to estimate 3D bounding boxes in real time for self-driving applications. One of the main contributions of our work are that our pipeline requires few computational resources to deploy, has an acceptable accuracy, and requires a CPU-only setup for both training and inference. Some of our main findings in this work are shown in the bar plot, where approximately 44% of detections have a 3D intersection over union, about 50% with the ground truth. Furthermore, we trained the whole system with 1,136 images and LiDAR sweeps in roughly 32.8 seconds, and the proposed pipeline is also able to process a new data sample in approximately 18.4 milliseconds or 55 FPS in a CPU-only setup. We also obtain an average testing accuracy of 87.1%, and the input size of our images are 1600 per 900 pixels, whereas the Center Fusion baseline compressed them by half. Well, that is it for now. I hope you enjoyed. If you want to find out more, please visit our work. Thanks.